afternoon, everyone. You're looking at a live view of the SpaceX launch site at Cape Canaveral Air Force Station, about an hour east of Orlando, Florida. You can see the Falcon 9 rocket there with the Dragon spacecraft on top. This particular Dragon has many upgraded capabilities, and we're looking forward to sending it to the International Space Station today. It's a blustery day out at the Cape so far, threatening us with stormy weather and thick clouds, but so far we're still within all allowable thresholds, and the range has us at about a 60% likelihood of permissible weather, so we're pressing on towards launch in just under 40 minutes. Welcome, and thank you for joining us. I'm Sarah Walker from the Mission Management team here at SpaceX. I'm a manager, integrator, and cargo specialist for Dragon cargo missions, just like the one we're launching today. And I'm joined here by John Innsbrucker, the Falcon 9 product director. John will be giving us updates on vehicle, weather, and range status throughout the afternoon as we count down to launch. We're webcasting to you live from SpaceX headquarters in Hawthorne, California, where we both design and build the Falcon rockets and Dragon spacecraft. Today's mission is CRS-3, the third operational cargo resupply mission contracted by NASA to bring food, supplies, and science experiments to the International Space Station. And it's actually the fifth flight of SpaceX's cargo Dragon spacecraft in all. SpaceX provides the world's only resupply vehicle that not only brings supplies to the International Space Station, but also brings back the cargo that astronauts need to send back to Earth. Later in today's webcast, we'll tell you all about our Dragon spacecraft and CRS missions, giving you an inside look at how Dragon is built and packed, and talking more about NASA's objectives for the ISS and the payload Dragon is carrying. But first, let's go to the rocket on the pad and get an update on today's mission from John Innsbrucker.
Good afternoon. I'm John Innsbrucker, the Falcon 9 Product Director, and welcome to our second launch of 2014, the second of many launches planned for this year. Now, I've been listening to the countdown during the last few hours, and I'll be providing you status updates as we go through our webcast this afternoon. This afternoon here in Hawthorne, California, where we're watching the Falcon 9 and Dragon spacecraft counting down. This is the exciting part of the job for the team, the launch. But today it's doubly exciting because we're also flying the SpaceX Dragon spacecraft to and from the International Space Station. And the energy and enthusiasm will continue to build here on our factory floor as people begin gathering outside of our Mission Control Center over the next half hour as we get ready to watch the launch of Falcon 9. Now the Falcon 9 is currently counting down. We're just under T-minus 37 minutes. Our liftoff is targeted for 3:25:22 Eastern Daylight Saving Time, or 19 hours, 25 minutes, 22 seconds Universal Time. We'll be flying from our Falcon 9 launch pad at Cape Canaveral, Florida, Space Launch Complex 40. Now, as you can see, today's launch is a little different than the last few that we've broadcast. Today, the Falcon 9 is not topped by a satellite inside of a payload fairing. Instead, we're carrying the SpaceX Dragon capsule with cargo to the International Space Station and then returning experiments from the space station. Currently, our status out of Cape Canaveral looks good. The SpaceX team is working on no issues on the Falcon 9 rocket. We were horizontal in our hangar at the launch pad yesterday, where we did the late load of cargo into the Dragon spacecraft. This is the last minute items, freezers, for example, that our NASA customer puts on board just before we go to the pad. We rolled out of the hangar early this morning and went vertical just as the sun was coming up. We're now vertical, and we've actually did propellant loading at about T-minus 3.5 hours. We loaded fuel and liquid oxygen onto the first and second stages. We've currently got about 850,000 pounds of propellant on the first stage, 200,000 pounds cleared, receiving telemetry, so the Air Force support systems look ready to go. The big thing that we're watching right now is the weather. Just recently, the weather officer updated the probability of good weather to 60%. We're currently green, but we're continuing to watch the thick clouds, the possibility of lightning, and the electric field building up at the launch pad ground level. But for the moment, everything's looking good for an on-time launch at 25 minutes and 22 seconds after the hour. So we'll keep our fingers crossed, Sarah, and hope that the weather brings us good luck this afternoon.
Today's launch, as John said, is scheduled precisely for 12:25:22 p.m. Pacific, which is 3:25:22 p.m. Eastern. For the daytime launch, we're hoping for some good video on the way to orbit, clouds permitting. The launch window is instantaneous, a 1-second window, but if we miss today's liftoff time due to weather or any other reason, we can reset and try again tomorrow, April 19th. This launch is the third of at least 12 missions to the International Space Station that SpaceX will fly for NASA under the Commercial Resupply Services contract. In December 2008, NASA announced that SpaceX's Falcon 9 launch vehicle and Dragon spacecraft had been selected to resupply the space station after the end of the shuttle program in 2011. Under the CRS contract, SpaceX is restoring an American capability to deliver and return significant amounts of cargo, which could include live plants and animals, to and from the orbiting laboratory. If all goes as planned, Dragon will arrive at the station on Easter Sunday, April 20th, when it will be grappled and berthed to the complex for an expected 4-week visit. Dragon is scheduled to return to Earth on May 18th for a parachute-assisted splashdown off the coast of Southern California. Today, Dragon is filled with about 4,600 pounds of supplies and payloads, including critical materials to support more than 150 investigations underway by the space station crew. Dragon will carry 4 powered payloads in its pressurized section and 2 in its unpressurized trunk, a first for SpaceX. After its brief stay on station, Dragon will return with about 3,600 pounds of cargo, including crew supplies, computer resources, science experiments, biotechnology, and space station hardware. Science payloads include optical payload for lasercom science, OPALS, which will test the use of laser optics to transfer information to Earth from space. The Vegetable Production System, VEGI, a unit capable of producing salad-type vegetables in space, and the T-cell activation and aging experiment that seeks to understand the cause of depression in the human immune system while astronauts are in microgravity. In addition, the High Definition Earth Viewing Investigation, or HDEV, includes 4 high-definition cameras to be placed on the space station's exterior for use in streaming live video to Earth for online viewing. Finally, after Dragon separates from the Falcon 9 second stage and heads towards station, that second section of the Falcon 9, the Falcon 9 second stage, will deliver 5 CubeSats to orbit as part of the CRS-3 mission, contained in 4 deployer units called P-pods. Now, here's Jessica Jensen with a little more information on today's launch of the CRS-3 mission.
My name is Jessica Jensen. I am the program director here at SpaceX for NASA's Commercial Resupply Services contract. What we do is we take cargo to and from the space station for NASA. They have paid us under a commercial contract to deliver this cargo safely, reliably. We still have to follow all the same rules. Just because we're a commercial contractor doesn't mean we can get away with doing things in a different way.
And liftoff of the Falcon 9 rocket and Dragon.
These missions are hugely important to NASA. There is an active space station up there, the International Space Station. There are always crew members up there, so we have to make sure that they are constantly resupplied with food, laptop batteries, all kinds of different supplies that they may need. Additionally, the space station is responsible for executing tons of different science experiments. SpaceX has currently the only vehicle in the world that is capable of bringing back significant amounts of cargo safely to Earth.
Splashdown, splashdown.
This is going to be our 3rd commercial resupply mission under this contract. We're going to go out through CRS-12, so we have a bunch more to go. And after that, the space station is still going to be around. And so we're all very excited about this business and the prospect of the future with the space station.
Our primary objective at SpaceX is delivering our customers' payloads safely and reliably to orbit. SpaceX is seeking to deliver the most reliable launch vehicles and spacecraft ever flown, and to do that, we continuously advance the boundaries of what's possible, both technologically and organizationally. It's challenging, but it's the only way to make real progress towards our ambitious goals. Now, let's look at the past Dragon missions and their successes in another brief video.
And launch of the SpaceX Falcon 9 rocket
as NASA turns to the private sector to resupply the International Space Station.
Currently to date, we've launched 4 Dragons. The first one was under it's called the COTS contract, and what it was before we could start these resupply missions to the space station, we had to prove to NASA and ourselves through some demonstration missions that we'd be able to meet all the objectives, berth with the space station safely. So we had 2 missions under that contract, and our first one was back in 2010, and that's where we sent Dragon into orbit. It did 2 orbits around the Earth, and then we re-entered it to Earth safely. Then after that, we were actually allowed to proceed on our next mission and actually berth with the space station. So we actually were able to deliver some supplies back then and bring some back home. Since then, we've had 2 fully operational missions, CRS-1 and CRS-2, and here we are now for CRS-3, taking up more cargo than we've ever taken up before.
Now we're just under 29 minutes from launch, and we continue to look good in all areas out at Space Launch Complex 40. Now it's a quiet time in the countdown for the engineering team on both Falcon 9 and Dragon. They're looking at their systems, seeing how things have trended during the morning and the afternoon as we've gone through the countdown, getting ready for what we have is a readiness poll that will occur at T-minus 13 minutes. Now on the launch vehicle side, we're continuing to top off liquid oxygen on both the first and second stages. Given the temperatures in Florida, a little bit of liquid oxygen boils off, and you can see that gaseous oxygen coming off of the vehicle is the white plumes up at the top of the second stage and again at the top of the first stage. We continue to replenish liquid oxygen up until the last minutes of the count when we close the valves and pressurize the stage for flight. The spacecraft also remains go for launch. Their last events are going internal at T-minus 8 minutes, and then as we transfer radio frequency systems over to carry telemetry down to the ground as the vehicle lifts off. The Air Force Range continues to monitor their systems. They have the required assets up, ready to support the launch. The good news is we're also looking at on-orbit traffic. There are no what we call collision avoidances required, so we are cleared green to take off from our runway at Launch Complex 40 right on time at 25 minutes and 22 seconds after the hour. Finally, on the weather, we've been releasing balloons looking at the upper altitude winds during the day. So far, everything continues to look good. While the weather has been marginal all day, the upper altitude winds currently are good, and we can fly the Falcon 9 safely through the winds. Meanwhile, down at ground level, we continue to monitor the thick clouds, the possibility of lightning, the electric fields, making sure that none of the launch criteria are compromised. But currently, weather says we are green on all those conditions. So we've got a booster, a spacecraft, we've got a range, and we've even got the weather cooperating. So at T-minus 26.5 minutes, everything's looking good for the launch. Now, many of you may be curious about how we put the Dragon spacecraft together, how it comes together in our factory here in Hawthorne, California. We've got a short video we'll show you right now.
My name is Joy Dunn. I'm the production engineering manager for Dragon. My team is primarily responsible for the build and integration of the spacecraft that you see behind us right here. So the Dragon production line takes quite a lot of people to get these vehicles built and shipped to space. We have well over 100 people on staff supporting us. This goes from technicians to production engineers to quality engineers. All of these people are involved in order to build the vehicles you see. Ideally, it would take about 12 months in order to build a capsule. So this is from starting the weldment all the way through shipment to the Cape. And then the Cape processing time is about 1 to 2 months until we actually fly. After it lands back in the Pacific Ocean at the end of flight, we'll then ship the capsule from California back to Texas, where it undergoes decontamination and then any final processing. So a clean room, as you can see behind me, is basically a clean facility in order to process our hardware. It keeps it much cleaner than the rest of the outside factory. We use that with HEPA filters, special air conditioning to maintain temperature and humidity, all of that in order to keep the capsule clean and safe for flight. In order to enter the clean room, you need to wear a full smock, and then after that you'll need to put on a hairnet to contain all of your hair and also shoe covers for any dirt on your shoes. The engines on the capsule are known as Draco. So these thrusters are 90-pound reaction control thrusters that control the movement of the spacecraft in orbit. There are 18 of them per vehicle, 4 per quad in half the quads, and then 5 per quad in the other quads. The 5th engine in those redundant quads are used for redundancy situations. So if any of the quads were to fail during flight, that 5th engine would draw from propellant on the opposite side of the capsule in order to still have a successful mission. Currently in production, we have 2 directly behind me in the Dragon clean room undergoing final integration. We have a third one in the clean room behind that that's doing all the propulsion integration. And then we have 2 vehicles as well on the structures assembly line. So we have a full 6 Dragons in work right now. So I've been a space nut ever since I was a little kid, always wanted to be an astronaut. Still hasn't changed, you know, all these years later. So yeah, I would most definitely want to fly on one of our Crew Dragon vehicles when it happens. That's one of the main reasons I came to SpaceX about 5 years ago.
SpaceX is the world's fastest growing launch services provider. Our launch manifest is populated by a diverse customer base, including space station resupply missions, commercial satellite launch missions, and U.S. government science and national security missions. Our last 2 Falcon 9 launches have delivered satellites to geosynchronous transfer orbits. But as we've discussed, today's mission is to take cargo and supplies to the International Space Station for NASA. The next video shows you up close what happens once we get to station.
So a lot of people wonder, what is SpaceX's relationship with NASA? And it is, they are our customer. What happens is, you know, a while back they decided that they needed more cargo missions to and from the space station, especially now with the shuttle program gone away. So what they did is they put out a proposal for commercial companies to bid their spacecraft to take just cargo, not crew, to and from the space station. We won part of that contract, which is great. That's how we built the Dragon vehicle.
2, 1, 0.
The Falcon 9 is the launch vehicle that carries Dragon into space. After launch, it will take approximately 2 days for Dragon to make its way to the International Space Station. In order to berth with the ISS, NASA astronauts use the Canadian arm to grapple Dragon and pull it in closer to the station. As they get closer, they check everything out, and Dragon will be pulled all the way in where it berths onto the Harmony module.
And so this is the control station, and what you see over here on my left, this controls the translation of the robotic arm. And then over here we have rotational control. And then this middle computer is where we actually take the robotic arm into the different modes that we do have. And then on our left over here we have a control panel for the various monitors. So what we're doing when we're grappling is I'm watching on this monitor basically a target on the vehicle, and I've got an overlay on it that allows me to line up the robotic arm with that vehicle, and I just drive right in. If you look in the middle, you can see those cables. Those are what we call the snares, and when we go over the pin that's on the vehicle and I pull a trigger, it causes those cables, those snares, to close around that pin, and that's how we grapple onto a vehicle.
At that point, the crew will pressurize the vestibule, and after that they can open the door on the space station side, then they can go in and open the hatch on the Dragon side. And then this is what allows the crew to go from the space station right into Dragon.
Well, we're just over 21.5 minutes to launch. Everything continues to look good for an on-time launch at 22 minutes, 25 seconds after the hour. We're continuing to work no issues on the Falcon 9 or Dragon. Now, you may have noticed in the views of the rocket on the pad an addition on this flight, and that's the landing legs that are on the Falcon 9. There are 4 legs on the first stage. They're 25 foot tall. These legs will be a crucial part of what we're aiming for, which is a reusable rocket. Now, during ascent, the legs are passive. They don't open, they stay locked against the vehicle. Our goal right now in this flight is, as always, make sure that the customer is delivered safely to orbit. However, once the second stage separates and carries Dragon on into orbit, the first stage will re-enter. So while the second stage is going into orbit, the first stage will be attempting an experimental landing in the Atlantic Ocean. This is the first time we'll try it with the legs, so as our boss says, the odds for doing something the first time like this aren't great, but we learn by doing, and we'll see how things come out here. Now, today's launch window is also 1 second long. This is a little different than our past flights where we had a longer launch window. So if we had a problem in the countdown, we could hold it T-minus 13 minutes, or as you've seen, if we had a problem inside terminal count, we could recycle the countdown, come back to T-minus 13 minutes and give it another try. Now in today's case, with 1 second, which is the optimum time for Falcon 9 to put Dragon into the space station's orbital plane, we're only going to get 1 try at this. So if we hear a hold inside of T-minus 13 minutes, the expectation is that would be a scrub for the day, in which case we'll look at recycling and launch opportunities on future dates. Right now, the backup launch opportunity would be tomorrow. Now currently on the Falcon 9, we're continuing to do the LOX topping. That'll go right up on into the last minutes. Now once we get inside at T-minus 10 minutes, we're going to open pre-valves on the Merlin engines, begin chilling in the turbo pumps, getting ready for ignition. So you'll start to see gaseous oxygen coming out from the base of the rocket. We'll also see the transporter erector strung back recline around 6 minutes as we get ready to fly Falcon 9 and Dragon to the space station. We'll also do final polling of Dragon also as part of the T-minus 13-minute poll, and we'll listen into that when that time comes up. So as of now though, Falcon 9 and Dragon are ready to launch. The Air Force range is still ready to support. They've got their capability, and the weather continues to cooperate. We've still got green conditions, but we'll be monitoring that all the way down to the last seconds of the countdown. But for now, everything's looking good. We're keeping our fingers crossed as we count down. Now on this mission, we're carrying cargo for our NASA customer. So you might like to get an idea of what's on board Dragon as it heads into orbit to the International Space Station.
My name is Jason Tenenbaum. I'm a mission operations engineer, and I am a mission director for our cargo missions. So this is CRS-3. It's the third operational Dragon for mission, and Dragon carries both pressurized and unpressurized cargo. So on the pressurized side, we're carrying a variety of supplies, hardware, and research that goes up to the space station. This is a single cargo transfer bag from NASA. The cargo bags come in standard sizes, so this is a single. They come in sizes that range from this size bag all the way up to 3 times this bag. This bag itself is about 17 inches by 19 inches by 10 inches. We can accommodate a variety of the different sizes of bags in Dragon. So they have single CTBs all the way up to triple CTBs. And then they also have M bags, which are larger bags that we put in Dragon, and they can essentially be up to 10 times equivalent sizes of this bag. The majority of the cargo that we receive from NASA comes at 1 month prior to launch. And then we also actually receive cargo the day of launch and load that. It includes a lot of time-critical cargo that NASA wants to deliver to us at the last minute so they can get some more value out of the research they're doing. So there's a significant amount of powered cargo and late load cargo that goes into Dragon. So we're carrying hardware that goes up to station like the short EMU. It's essentially an upper half of the AVA suit that they use to do spacewalks. We're carrying the legs of Robonaut, the robot that they have on station that'll help them do tasks to offload the crew so they can do more research. And we're carrying lots of food and other experiments. For the unpressurized cargo, we're carrying 2 different experiments, Opals and HDEV, and those both are flown inside Dragon's trunk, so they're unpressurized payloads, and they're extracted out from Dragon using the robotic arm on the space station. So overall, we're really excited to be a part of the team with NASA and helping to contribute to the research and other things they're doing on the space station.
I just looked down at the factory floor and I can see a dedicated team starting to gather to support the launch. The excitement builds, especially around a Dragon mission, as there are over 3,000 SpaceX employees that play a vital role in the mission's success. After today's launch, you can continue to follow us at SpaceX.com and our social media pages for mission and company updates. And we now have an online SpaceX shop open too. Check it out at shop.spacex.com. Now, before we get to our final status updates and switch over to the countdown net, I want to tell you a little bit about the Falcon 9 rocket cam, which will serve as our primary video feed later in the webcast. This camera is mounted on the second stage, looking down about 12 stories above the launch pad. It's from this camera that we're going to watch the 10-minute ride all the way to orbit. Okay, I think it's time for John to give us one final update on the vehicle, weather, and range status before launch.
Well, we're just inside 15.5 minutes. Everything continues to look good on the Falcon 9 and the Dragon. No issues are being worked. The engineers are doing their last internal data checks, getting ready for the poll by the SpaceX launch director. That'll come at T-minus 13 minutes. Following the poll at 13 minutes, the team will get instructions on what they should do as we get into the terminal countdown sequence, which will begin at T-minus 10 minutes. At that time, the ground and flight computers are taking over, counting down the systems on the rocket and the underground systems as we get down to T0. Now, as I mentioned before, if we have a hold at that point, given the short launch window today, that will probably be a scrub, and then we'll see what our next launch opportunities are. Now the range continues to be ready to support. Everything's fully mission capable to follow Falcon 9 and Dragon into orbit. And we're continuing to be good on the weather. We're still green for the launch commit criteria. We've also gotten the last balloon data, and that shows that the upper altitude winds are also go. The vehicle can safely fly through the speed of the winds as we climb through altitude on the way to space. So right now the Falcon 9, the Dragon, the range, and even the weather, everything's cooperating. So we're looking to get to an on-time launch attempt in just under 14 minutes from now. One other comment, we talked about landing legs while I've got a minute. If you happen to be on YouTube, yesterday we had a successful test flight of our F9er development vehicle. We've now posted some outstanding video from that test flight, and you can take a look at that after the launch, hopefully. But for now, everything's looking good. Now, one comment, we've had 3 great launches in the last months. Our customers we have successfully put in orbit, but now we're focused on what's in front of us. So we've done all those reviews, we've made sure all the issues are closed, we've done the risk checks, done all the homework. Teams put in a lot of hours on Falcon 9 and Dragon, both on the flight and the ground systems. So we've done our homework, we're ready to go, and now we'll listen in to the readiness poll.
For launch, FTS.
FTS go.
Prop.
Prop go.
AVI.
AVI go.
GNC.
GNC go.
Ground.
Ground go.
VC.
VC go.
GC.
GC go.
RC.
RC go.
DC.
DC go.
OSM.
OSM go.
Brock.
Go.
CE.
Go.
MD.
MD go.
LD.
LD go.
LD, verify go to initiate terminal count.
LD go for initiate terminal count.
T-minus 12 minutes. VC and DC start the terminal count auto sequences set to start at T-minus 10 minutes.
Copy that, proceeding. Copy that.
If a hold is called from this point forward, the terminal count auto sequence will be aborted. Indicate an abort or hold condition by saying hold, hold, hold on the primary countdown net. In this event, the VC will immediately abort the auto sequence. The VC shall not abort the auto sequence after T-minus 10 seconds, and operators shall not call a hold after T-minus 10 seconds. If a hold is called, all operators proceed to the terminal count abort steps in section 10.62. Attention all personnel, stand by to pick up the count, T-minus 10 minutes and counting. On my mark. Three, 2, 1, mark. VC announce auto sequence has started.
Terminal count has started.
GCVC standby on FireX.
Standing by. Standing
RC
by.
start the camera video recorders.
Roger.
OSM set launch enable to flight.
Flight.
First stage engines are chilling in. Ground T-tip system setting up.
Engines are chilling in.
Ground helium spin start system is set up.
T-minus 9 minutes. T-minus 8 minutes.
Nitrogen ACS closeout has started. Heater end stage 1 has started.
T-minus 7 minutes.
Heater end stage 2 has started. Internal stage 1 and stage 2 have started. Ground TVC tank is pressing.
T-minus 6 minutes.
First and second stage tanks are pressing in preparation for strong back retract. Stages on both tanks are at pressure. Crown TVC tank pressed to 1300 psi.
T-minus 5 minutes.
Strong back is retracting.
T-minus 4 minutes.
GNC confirms good stage 2 TVC motion.
And we've reached 77.7 degrees. Pinning strong back in retracting position.
FTS is on internal power. FTS is armed.
T-minus 3 minutes. LD, verify go for launch.
LD, go for launch.
Vehicles in self-alignment. First stage tanks pressing.
Rock, verify range go.
Range green.
Vehicles back in manual mode. Vehicles in auto idle. Vehicles in startup. The flight computer has control of the vehicle.
Dragon. Confirm Dragon is in startup. DC countdown net, confirm you're in startup.
DC confirms flight computer is in startup.
Second stage pressing.
Tanks are at flight pressure. Engines are chilled for flight.
T-minus 30 seconds. T-minus 20. T-minus 15. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 0. Liftoff of the Falcon 9. Falcon 9 has cleared the tower.
First stage propulsion is nominal.
Solid tunnel turns to the left on both stages. Power system nominal.
First stage propulsion is nominal.
Power systems nominal. Solid telemetry lock on both stages.
T plus 110 seconds, altitude 24 kilometers, speed 785 meters per second, downrange distance 13
MVAC
kilometers.
is chilling in.
Vehicles flying down the nominal. T plus 2 minutes 30 seconds. Vehicle vehicle 63 kilometers altitude, speed 1.8 kilometers per second, downrange distance 55 kilometers.
Stage separation confirmed.
And we have MECO 1. And MVAC ignition.
T plus 3 minutes. Vehicle altitude 103 kilometers, speed 2 kilometers per second, downrange distance 103 kilometers.
Stage 2 propulsion is nominal.
Falcon power systems nominal. Solid telemetry lock on both stages.
T plus 4 minutes 45 seconds. Vehicle altitude 205 kilometers. Speed 2.4 kilometers per second. Downrange distance 285 kilometers. Vehicle continues to fly down the nominal trajectory.
All Dragon tracking stations nominal. TDRS nominal.
Stage 2 propulsion is nominal.
Falcon power systems nominal. Solid telemetry lock on both stages.
T plus 6 minutes 40 seconds. Trajectory status 284 kilometers altitude. Speed 3.6 kilometers per second. Downrange distance 600 kilometers.
Stage 2 propulsion still nominal. Stage 2 propulsion is nominal.
T plus 8 minutes 15 seconds. Altitude 322 kilometers. Speed 5.3 kilometers per second. Downrange distance 980 kilometers. Still getting excellent video of the first stage, having performed its entry burn, and excellent video from the Air Force New Hampshire tracking station on the second stage. Vehicle continues to fly down the nominal.
Terminal guidance has begun.
And we're in terminal guidance. Stand by for engine cutoff.
FTS is safed.
Dragonfly computers in separation.
And we have SECO 1.
Newfoundland ground station has acquired Dragon.
Dragon deploy confirmed.
Enabling Newfoundland telemetry.
Dragon lost a
This is
signal
John
from
Innsbrucker. You're looking at the live shot of Dragon, successfully separated from the Falcon 9. We're in a good orbit. We're watching Dragon slowly drift away. Now, right now, the second stage is beginning to turn. That's a normal event. So we're probably not going to get to see the solar rays come out on Dragon from the second stage, but we'll try to see what the cameras can bring you. We'll follow along and go back in just a minute, see if we've still got coverage. But right now, it's a great mission. We're where we want to be. So let's go back and just take a look, waiting to see if we can maybe get video coverage of the arrays coming out on Dragon.
Dragon is in array deploy. Dragon has good solar array deploy.
Dragon has nominal command and telemetry from TDRS.
Prop global.
As you can see, we're all very excited here at SpaceX for another successful launch, and we hope you enjoyed watching from home. Today was an incredible day for me and the rest of the Dragon team, and we can't wait for the cargo to arrive to station in just a few days. Well, that concludes our webcast, and on behalf of all of us here at SpaceX, thanks for tuning in.
And as you can hear, a lot of applause in the background. Looks like we've got another successful launch of the Falcon 9. We'll be releasing updates on how Dragon is doing, and maybe we'll also get some insight on what happened at the first stage recovery. But tune in with us on the web so we can see how Dragon's doing as it makes its quick flight to the International Space Station. But right now, for Sarah and myself, great afternoon at the Cape, successful flight. And with that, we're going to sign off, check our social media web pages for updates. And we'd like to also thank our NASA customer for the confidence in us and hanging with us through the bad weather today as everything cleared up and everything came together and it looked great, Sarah. And with that, thanks to all of you for watching us on the web. And as I said, check on our media pages for updates. And with that, we're going to sign off and say good afternoon, good evening, or good morning to wherever you are around the world. Goodbye from SpaceX headquarters here in Hawthorne.